Hello guys, so today we are going to do chemistry chapter 1 matter, and I'm not going to go in much detail of this chapter because it is you can say almost same as physics chapter 1 matter. So there are so many terms which we have already studied in physics chapter 1 and they are repeated in this chapter. So we are not going to repeat everything all over again, but I'm just going to give you an overview. So after watching this short overview of this chapter, I want you to solve the exercise from your textbook, which I'm going to share in the book in your group. And if you have any doubts, then you can definitely let me know. But I don't think that there will be any doubts because both the chapters are absolutely identical to each other. So the first topic of this chemistry chapter 1 is material. So what is material? The term used for particular kind of matter is called material. So these are certain definitions which are there in this chapter and little bit different from the definitions which we studied in physics. So you might want to remember these particular definitions. So what are the examples of material? Wood is a material, water is a material, marble is a material. So these are the examples of materials, and material is a particular kind of matter. Kind of materials. Now there are two kinds of materials. Now this was not there in physics. I will also tell you that what is new in this chapter, which is not repeated in physics chapter 1 matter. So these things, the kind of materials is new. Okay, homogeneous materials and heterogeneous materials. What are homogeneous materials? The materials which have same composition and same properties throughout are called homogeneous materials. So these are the keywords: same composition and same properties throughout. Okay, for example, pure common salt is a homogeneous material, and so is its solution in pure water. So if you take an example of common salt, pure common salt, it is a homogeneous material because it has the same composition and same property throughout. Also, if you put this salt in water and make a solution of salt in water, salt solution, that is also homogeneous material because the composition of that particular salt solution is same throughout and its taste is also same, right? So it's a homogeneous material. Heterogeneous material, the materials which have different compositions and different properties in their different parts are called heterogeneous materials. In a marble rock, we can see gray or red grains of other materials. I'll give you one better example. If you take an example of sand plus water, if you add some sand and water, that is heterogeneous material because you can see that sand is separate in water. It does not mix thoroughly. It has different composition. At the bottom of the container, all the sand has collected itself, right? So sand plus water is basically a heterogeneous materials example. Okay, let's go ahead. Substances. A homogeneous. So we were talking about material. Now we are talking about substance. A homogeneous material. Remember the definition of substance. A homogeneous material which is made of only one kind of atoms or molecules such that its composition remains same throughout is called a substance. A substance is a substance is something which is made up of same kind of atoms or molecules, only one kind of atoms or molecules, and its composition is same throughout. It is a homogeneous material. This material is known as substance. Sodium chloride is a substance because it has 23 parts of sodium and 35.5 parts of chlorine by weight in its composition. Similarly, pure alcohol, pure water, Pure gold. The word pure is very necessary over here because it should be made up of only one kind of atoms or molecules. Pure silver, these are all substances. So now you understand what is the basic difference between material and a substance. Material could be homogeneous or heterogeneous, but substance is always homogeneous. Materials could be made up of one or more kind of atoms. Like even if it is a homogeneous material like salt solution, it is made up of salt molecules and water molecules. It is not a substance, it is material. Salt solution is a material, but only salt or only water is a substance, right? Then we have kinetic molecular theory of matter. Now this we have studied in detail in physics chapter 1. So I'm not going to repeat it word by word, but I'm just going to give you an overview as I told you. So matter is made up of small particles called molecules or atoms. Particles are in the state of random continuous motion or unending motion. With the supply of energy, heat energy, the kinetic energy of the particles increases and they start moving more vigorously. Reverse happens if the matter is cooled. If the heat is removed, the kinetic energy of particle decreases and they start moving less and less vigorously. The particles attract each other with a force. This force is called cohesive force. If the particles are of same kind, they attract each other with cohesive force, and if the particles are of different kinds, then they attract each other with adhesive force. This we have studied in the first chapter of physics very well. The force of attraction between particles decreases if the distance between them increases and vice versa, right? So force depends on intermolecular distance. So all these properties we have already studied in way much detail in physics chapter 1. States of matter and their properties, this also we have studied. There are three states of okay, this page is repeated. There are three states of matter: solid, liquid and gas. So what are the properties of solid? It has definite shape and volume. Solids are generally rigid. If it is elastic like rubber, then on application of force it will change its shape. On removal of force it will regain its original shape. Solids have any number of free surfaces. Intermolecular spaces are very small. Intermolecular forces are very large. Density of solids is very high. I explained what is density in physics chapter 1. The dimensions of solids do not increase in large proportion on heating or cooling. When two solids are kept in contact with one another, they do not mix with each other. They do not diffuse. Explanation of a solid on the basis of kinetic model. So we explained why solid behaves as itself, why solid is a solid with the help of kinetic theory of matter. See, kinetic energy of molecules is least in solid. Kinetic energy of molecules is least and force of attraction is maximum. The molecules of solid can just vibrate about their mean position, that is talking about random motion, but cannot migrate from one position to another. And that's why solid have definite shape and definite volume. All metals, wood products, rocks of various kind, ice, they are all solids and they all have this property. Then there was liquid. Liquid has definite mass and volume but no definite shape. It takes the shape of the vessel in which it is kept. The force of attraction is there but less than solid and more than gases. Intermolecular spaces are large, larger than solids but less than gases. Liquids are slightly compressible than solids. Solids are not compressible. Liquids have only one free surface, that is the upper surface. Density of liquid is less than solids. There is an exception here. When we talk about density of liquid is less than solid, there is an exception. Exception is uh, wood. Wood has density less than water. Water is liquid, wood is solid, but still its wood's density is less than water. Liquids expand far more than solids on heating and contract far more on cooling. That's one very unique property. The particles of two different liquids can diffuse into one another depending upon the nature of molecules. For example, milk and water, they diffuse into one another, mix into one another very easily. But oil and water do not mix into one another. Oil floats on water. So they have explained why water or why any liquid behaves as a liquid on the basis of kinetic theory of matter, which we have studied in physics chapter 1. So we can say that kinetic energy of molecules of liquid is very large, and so the distance between the molecules. Thus attractive forces of molecules of liquid are small as compared to solid. Therefore, molecules of liquid are free to move about within this liquid, and hence, so molecules are free to move within the liquid. So liquid can easily take the shape of the container. However, volume of the liquid does not change because molecules do not leave the liquid, right? So it has fixed volume. Examples of liquid: water, alcohol, benzene, milk, mercury, kerosene, oil. These are all liquids. Gas. A gas is a state of matter which has definite mass but no definite shape and no definite volume. A gas contained in a vessel has definite mass. It occupies the entire space of the given vessel in which it is enclosed. Intermolecular spaces of gases are very large as compared to solids and liquids. It is due to this reason that gases are highly compressible. Intermolecular forces are negligible. It is due to this reason that they fill the entire space. Gases have no free surface. Gases expand to a large extent when heated. On cooling, they contract to a large extent. They diffuse into one another very fast, very rapidly. They mix with each other very rapidly and form homogeneous mixture. The best example of homogeneous mixture in gases is air. In air, there are so many gases, right? It is on account of large intermolecular spaces that gases diffuse into one another very rapidly. The density of gases is extremely small as compared to the solids and liquids. So why gas behaves as a gas? See, intermolecular spaces are very large. So force of attraction is very small, negligible. And kinetic energy is also very large. So particles are free to move in any direction and can fill any space. Why gases take the space of the container? Because of these reasons. Thus, the gas have no definite shape and no definite volume. It is because of large intermolecular spaces that gases can be easily compressed. All these things we have uh, studied in so much of detail in physics chapter 1 that I'm not going into detail, okay? Please understand that. Oxygen, nitrogen, hydrogen, carbon dioxide, sulfur dioxide, these are all examples of gases. Then we also studied about the interconversion of matter into different states, right? And we know that by altering these two conditions, that is temperature and pressure, the various states of matter can be interchanged. And we studied the definitions of melting, freezing, melting point, freezing point, right? Why is melting point determined? Okay, this is new. Let's study this. The melting point of pure substance is always constant quantity and is a good measure to find the purity of solid. For example, melting point of pure ice at a pressure of 76 centimeter of mercury is 0 degrees Celsius. However, if solid is not pure, then it does not have sharp or fixed melting point. As a matter of fact, impurities generally reduce the melting point. For example, this is very interesting and important. For example, the melting point of paraffin wax is not sharp and can be anywhere between 62 to 65 degrees Celsius, depending upon the kind of compounds present in it. Right? If you put some ice also in water, I'm sorry, if you melt some ice also, and if you put some salt in ice, and then you check the melting point might have decreased. So by storing ice in salt, common salt, the melting point decreases. That is by adding impurity in it. These are general melting points of some common solids for your knowledge. Okay, then boiling or vaporization, condensation or liquefaction, we have studied this. Evaporation, we have studied in so much detail. Boiling point, condensation point, boiling point determined. Okay, so the same thing they have, same information they have given here regarding the boiling point also. Then sublimation, we have studied naphthalene balls, then ammonium fluorides experiment. Everything we have studied in physics chapter 1 very nicely and in detail. By altering pressure, what happens to the boiling point, that also we have studied. How gases differ from vapor. If you remember, I have discussed this in physics. A gas is a substance which exists in gaseous state such that its temperature is equal to or more than the boiling point of the liquid state. For example, oxygen, hydrogen, nitrogen, chlorine, carbon monoxide. These gases, they generally exist in gaseous state at room temperature, but vapor is a substance which exists in gaseous state when they are basically evaporated from room temperature. Okay, so its temperature is lower than the boiling point of the liquid state. Water's boiling point is 100 degrees Celsius, and below 100 degrees Celsius, if you find the vapor state, or sorry, gaseous state of water, you call it water vapor or alcohol vapor or HCl vapor, the same thing. Then uses of change of state of matter, how we can use steam, or what are the uses of steam they have listed here. You can just go through it. How steam uh, into how water is changed into steam, and heat energy which the steam has, which is used to drive the turbines in thermoelectric stations. Thermoelectric stations is um, electric power plants, electric power plants, or you can say thermal power plants. So in power plants, basically, uh, heat is generated by burning coal or some other means, and this heat is used to boil the water. Water produces steam. The steam is pressurized and thrown onto turbines. Turbines are huge fans. We are going to study these things in detail in coming chapters, or you can say coming standards. Very much in detail we are going to go. So don't worry about them. But these fans basically they rotate and they turn a generator, and this generator produces electricity. That's why they are known as power plant, a plant which produces power. Then for heating metal also steam is used. Then by liquefying air, we can separate oxygen and nitrogen gases, and oxygen is used for artificial respiration, like for hospitals. Nitrogen is used for making fertilizers. Room fresheners are based on the property of sublimation. Okay, this is something new which we have not studied. Law of conservation of mass. According to this law, the mass can neither be created nor be destroyed. So they've done one small chemical experiment. Please focus over here. Pour about 20 ml of solution of silver nitrate in a clean conical flask. Okay, so conical flask is basically your equipment which is used, which looks like this, which is used in a chemical lab. Okay, so this is basically your conical flask. In this conical flask, you have to pour 20 ml of solution of silver nitrate. Take an ignition tube and to its neck tie a long thread. Half fill, I'll show you how see, this is how it is. So you have to take a test tube and you have to put hydrochloric acid into it and tie thread to the neck of the test tube and hang it into the conical flask. Okay. Now what you have to do is basically you have to find the mass of the conical flask by physical balance and record that mass. That mass will be with the hydrochloric acid and the test tube and everything. Okay. Then what you do is you slowly lower this thread, you loosen this thread and lower this test tube into the conical flask. So what will happen, this silver nitrate, which is AgNO3, rightly written over here, plus HCl, these two chemical compounds, silver nitrate and hydrochloric acid, they will undergo chemical reaction, which we are going to study in further chapters, and they will produce new products, which is AgCl2, silver nitrate, silver chloride, I'm sorry, and HNO3, nitric acid. So new compounds are formed and chemical reaction has happened. But if you note the mass, record the mass all over again, you will find that there is no change in mass. Although new substances are formed, although chemical reaction has happened, but no increase in mass has been recorded. So this proves that the mass can neither be created nor be destroyed. So this is the law of conservation of mass, which was given by Lavoisier, the scientist named Lavoisier. Lavoisier demonstrated the importance of careful measurement of mass, which led to the discovery of another law, the law of constant proportions. And law of constant proportion also says similar thing, that the proportions in which two compounds are mixed together always remains proportional to the products, to the ratio of the products. So the ratio of reactants is equal to the ratio of product. That's what law of constant proportion was explained by Lavoisier, but that is not there in your chapter over here. So what we have to do is basically focus on the things which are similar to physics and those which are very, very new to you. There are very few things which are absolutely new, and try to understand them and try to finish this particular exercise. And there is a theme assignment as well. Okay, so this you have to do. That is your next task, and I'm going to see you in the next video. Bye bye.